Good day and welcome back to the EBN semester test exam preparation course. And in this video, we are going to be covering a typical semester test that you may face. This is a semester test 1 example. So the questions through here would be typical of a semester test, right? Okay, so to test the first chapter, they would ask something like this, where an electric stove with two electric plates and an oven is used to prepare the following meal, right? So a plate 1 with 1.8 kilowatts for 20 minutes, plate 2 with 1.2 kilowatts for 40 minutes, and an oven with 3 kilowatts for 30 minutes. Calculate the costs of electricity used for preparing the meal if the electricity costs 2 rand per kilowatt, right? So we need to change these quantities into a kilowatt hour quantity, right? So the cost is equal to your 1.8 multiplied by 20 over 16. We're using 20 over 60 because we're converting the kilowatt into kilowatt hours, right? And then we've got plate 2, which is 1.2 multiplied by 40 over 60, and we've got our oven, which is 3 multiplied by 30 over 60. Right. So this would be 2.9, right? This is instead of saying cost, it's not really cost, it's the energy used, right? Because the cost says the cost is 2 rand per kilowatt, right? So now the cost is equal to 2 rand multiplied by 2.9, which is 580. Right. And then the second part says if a constant 100 volt is applied to an element and the element uses 150 kilojoules over 1 minute, what is the size of the current flowing through the element? So for this one, we are going to use the fact that the power is equal to the change in work over the change in time, right? And you are told that 150 kilojoules is being transferred over 1 minute, which is 60 seconds, right? So this gives you a power of 2.5 kilowatts. But power is also equal to the voltage multiplied by the current, right? So therefore your current is equal to your power divided by voltage, and we're given the fact that there's 100 volts, so therefore we've got 2.5 K over 100, which is 2.25 amps, not 2.5, 25 amps. So the next question we're going to be looking at is this question, where you're asked to find the power that is related to the independent voltage source and the dependent current source. Okay, so the first thing that we need for you to find power, we know that power is equal to VI, right? So we need to find the voltage and we need to find the current that is going through our independent source, which is here, and our dependent current source, these two. Okay, so we know the voltage going across here between these nodes, right? We know that there's 6 volts, and because this voltage is being applied across the resistor, we know that I1 is equal to 6 volts over 6 ohms, which is 1 amp. This is just V over R. That's how I got I1, right? So, but we know that 3 amps is being delivered here, right? So this means that only 1 amp of those 3 amp goes that way, and the other 2 is going this way, right? So this means that we've got 1 amp here, and we've got 2 amps going this side. So this is how you determine how much current is going through our voltage source, right? Because this is the only way that this 3 amp source can be delivered, right? So the power of your independent source is equal to your VI, which is 6 multiplied by 2, giving you 12 watts. And then when you look at your dependent source, you can see that the current on your dependent source is 2 multiplied by I1, where I1 is equal to the current going through your 6 ohm resistor, which is 1 amp. So therefore the current going through here is 2 amps, right? So now the voltage going across there. So now that we know the current that is going through our dependent source, we need to find the voltage that is across the source, right? So if we look at this node right here, so we have our 2 amps coming in here from our voltage source, our 6 volt source here, and then we have a 1 amp coming in here from our 6 ohm resistor, and then you have 2 amps here with our dependent source, right? And then now we're asking ourselves how much current is going through this resistor here, right? So by looking at this, we can see that it's a simple KCL. You've got 3 amps coming in and 2 amps is leaving this way, so therefore 1 amp has to go down here. This is why 1 amp is going through our 5 ohm resistor, right? Because 2 amps coming in there, 1 amp coming in here, so therefore 3 amps need to flow out between these 2 nodes, right? So now the power of our dependent source here is also VI, and the voltage across it is, we've got a 1 amp going here across a 5 ohm resistor, which means there's a 5 volt across there, right? That's why this is 5 multiplied by the current going through it, 2, giving us a 10 watt power. The next question is, we are asked to determine R, the value of this resistor here, given that R equivalent is 161, okay? So first of all, you would see that you've got a series connection going on here. You've got a series connection going on here. Let me use a different color there. You've got a series connection going on there. And yeah, so then this gives you your 25. R 60 and 60, right? And then you have the series connection with your 30, with 100 here. Okay. So now the parallel combination of these two, 60 and 60, gives you an overall of 30 here. Right. This is because R is equal to R over N for, so the R equivalent is equal to the R over N, where N represents the number of resistors in parallel if they're the same resistors. Like if you had 3 of them in parallel, then the equivalent would be 20, because 60 divided by 3 is 20. And here we have 2 of them in parallel, so 60 divided by 2 is 30. Or you could have done it the old-fashioned way of writing them in parallel. Okay. And then now you have these two in parallel, in series. So then this means that you can draw one resistor here of 60 ohms. And now this is the diagram that you're looking at. So now you've got your resistor R in parallel with the 60. This should be 60. So you've got R multiplied by 60 over R plus 60, and that is being added to 100 and to your 25. This is your R equivalent, right? The R equivalent of this whole circuit. So now to find your value of R, you've got 161 minus 125 is equal to R multiplied by 60 over R plus 60. So solving this equation is pretty easy when you have the FX991ES plus calculator, or this version of calculator which can do simultaneous equations. So all I did is I just typed in what I just had in, and what I used for the equal sign, I pressed alpha solve, which is this button, so that I can get this equal sign, right? And then to solve the answer, I press shift solve, and then you will find that the answer is equal to 90, right? So that is the value so that will save you time when you are doing these problems. And this is how I'm going to solve problems. I'm not going to write out the final step, because I've shown you how to solve one simultaneous equation on a calculator. So when it comes to a simultaneous equation happening, I'll just type it into the calculator and say the answer, and I'll assume that you can also do it from now on. So this is the next question. Determine RAB. You are given this T network, this very boring Y network that has to be obviously transformed into a delta network, because you have this going on here, right? And because of that, you can't really find anything parallel, because you've got this point and this point as one node, and nothing's really happening. So you have no choice but to transform it. And this is one of those where you will have to have remembered the equation that says RA is equal to R1 R2 plus R2 R3 plus R3 R1 over R1, right? So this is our equation that we're going to be working with, transforming our y into a delta, right? So this will be A, B, and C there. That is RB, RA, and this is RC, C, and this is 1, 2, 3. This is something that there's no way to get around it. You are going to have to memorize the equations for this, but at a later stage, what they usually do is that they make all of these three components equal. This is just a semester test 1 example where in a semester test 1 you are going to be hit with a question like this where they want you to have remembered and memorized this question, right? So now for you to get your values, remember, for you to get from RA to, if you want RB, you change R1 to R2, and if you want RC, you change R1 to R3, but the top remains the same. Remember the way that the equations are, right? So then this gives you a value of 80 for RA. So RA is 80, and your RB and your RC are both 40. I rather would not like to spend time just clicking it into a calculator. There is nothing actually going on here when it comes to this. So to make the diagram a little bit simpler, what I do is I just sometimes do this. I erase those so that I can be able to see what is actually happening now, right? So when we look at this, we can see that RA is parallel to the 80 here. Let's go for a different color. So we've got this happening, then we've got that happening, and we've got this happening. So this makes our problem much easier, right? So because of this fact here, that RB is equal to RC, we can know that this result is going to be the same as this result. So there's no need to calculate one answer twice. And 40 in parallel 40, as we said, is now 20. So this means that this is 20 and this is 20, right? And the other one, we've got 80 in parallel with 80, giving us 40, right? So now we have to redraw the circuit, okay? So this means what we have now is our 25 here. Then we have what is happening here. Two 40s in parallel gave us a 20. And then two 80s in parallel gave us a 40. And then two 40s in parallel gave us a 20. Right. So now this is the resulting circuit that we have, right? So now we can see that we are finding the equivalent of here, right? So remember, now we have the circuit is going to be focused between this node and this node, right? We need to find the parallel between 20 and 60, right? So 20 in parallel with 60 is equal to, that is equal to 15 ohms, right? Now we can determine the resistance as seen through terminals A, B, because we have found the resistance on this side to be equal to 15, right? So now the total resistance seen through the terminals A, B is 15 plus 25, giving you 40. That is the answer to the question. This is the next question we are going to be taking a look at. So for the circuit below, it is given that I0 over IS is equal to 0.2 and the equivalent resistance is equal to 5 kilo ohms, and you must find R1 and R2. Okay, so first of all, you know that by current division that I0 is equal to R2 IS over R1 plus R2, right? So then this means that 0.2 is equal to R2 over R1 plus R2, right? So now you get that 0.2 is equal to R1 plus R2 is equal to R2. This gives you 0.2 R1 is equal to 0.8 R2, right? And then this means that R1 is equal to 4 times R2. And from our equation of two resistors in parallel, R equivalent, which is equal to 5K, is equal to R1 R2 over R1 plus R2. So this is equal to, now, so because your R1 is equal to 4 R2, you got 4 R2 squared over 5 R2. So then you're just going to substitute this into a calculator. 5K is equal to 4 R2 over 5. So this gives you a value of R2 is equal to 25 over 4, which is 6.25 kilo ohms. And then you get R1 is equal to 25 kilo ohms, because it's just 4 times R2.